Hi everyone, this channel covers motors. So today we have this engine. Today we're going to take apart this engine. This is a Mercedes-Benz SOM 447. It's an inline 6, turbocharged. The turbo has already been removed. The exhaust manifold has been removed. The turbo has been removed, so there's no turbo. So the engine operates in this position, meaning it's lying down. This engine is from a bus, a Mercedes bus. What's the reason for removing this engine? This engine started knocking. The bus was in service when the driver heard unusual engine knocking and noticed a drop in oil pressure. The driver turned off the engine and the bus was towed in. If oil pressure dropped, we need to find the cause. Somewhere around the crankshaft, maybe the main bearings, connecting rod bearings, possibly the oil pump drive, and so on. But still, when they brought the bus to the pit, they removed the exhaust manifold. Well, I decided to check each cylinder, that is, if we had something wrong with the cylinder, like let's say the piston got stuck to the liner, or for example a seat fell out or a valve broke apart. Then we end up with the exhaust manifold. One head's exhaust port could be wet with diesel, oil or coolant, for example. We removed the exhaust manifold, checked, and all the ports on all the heads are dry, meaning there's soot but no moisture. So the cause isn't in the seat, valve, head or cylinder. The knocking comes from the crankshaft, journals, connecting rods or main bearings. We decided to remove the engine because the crankshaft can't be accessed, removed or replaced while it's installed. We removed the engine and rinsed off the worst of the dirt at the wash. My task now is to take it apart, figure out the cause, find out why it's knocking, and also see what consequences this knocking has caused. Since the engine is already out, we'll fully disassemble it, removing the heads, taking out the pistons, and inspecting its condition. And once we know the reason for the knocking and the overall condition of the engine, a decision will be made about what to do with this engine. This engine belongs to our company. It's from our company's bus. I don't know if this engine will be reassembled or not, but it's likely because the bus seems to be in pretty good condition comparatively, compared to all the other buses in our company. What else do I want to say? There's no clutch now. The flywheel pressure plate and disc went to the Skoda bus, which needed a new clutch and returned to service. This bus will likely be out of service for a while. The clutch was taken off this engine and given away, and it's working now. So what more can I say? If we take a look, for example, there are sensors on the air manifold. Also, if we look at the cover, there were sensors installed here and so on. So at some point this engine was set up for electrogas. There was a pump with electrogas installed here. That was maybe 8 years ago or maybe 10 years ago, I don't remember exactly. I repaired this engine. We converted it to mechanical gas with a fuel injection pump with a mechanical gas drive with a gas cable. For what reason? The gas was sticking and the engine was running away. Since electricians couldn't find the cause, we converted the engine to a mechanical pump. We changed the fuel pump, camshaft and injectors. It's basically the same as it is now. I had an engine, a contract engine from Poland. It served me well. I don't know exactly, but about 10 years, I don't remember for sure. Let's start. The oil is already drained. As I said, now I need to remove the compressor there. The air conditioner compressor is mounted on that plate, along with fuel lines, a pipe, the fuel pump, etc. We first disassemble everything from the top, hang it up, remove the oil pan, then take off the cylinder heads and continue from there. That's it, so that's the amount of work we have for today. Let's go. I just removed the oil pan and immediately saw metal shavings on the third cylinder. So it turns out the third cylinder most likely, yeah, we can see it. The third cylinder's bearing is damaged. The connecting rod bearing fused to the crankshaft journal. We can see that there's metal shavings here. And what else do I see? I see that the crankshaft is broken, meaning there's a crack right here. What happened first is unclear. Either the bearing seized first, which caused the crankshaft to break, or the crankshaft broke first and the fracture goes right along the journal. The connecting rod bearing was damaged, so we'll disassemble and inspect it. However, the crankshaft is already broken. Here's the crack. It starts here and goes along this side, heading over there. And I can also see it goes this way onto the journal. So what does this tell us? If the crankshaft broke in the bearing seat under the main bearings, you'll need to take it to a machine shop to have it machined or replace the block. Well, the crankshaft, of course, obviously needs to be replaced. A different crankshaft and the connecting rod, this one also needs to be replaced. The connecting rod needs to be changed too. So far, these are the preliminary results. We're continuing to take it apart. Alright, so I removed the injectors, took off the rocker arms and pulled out the push rods. And now I need to unscrew the cylinder heads. As we remember, this impact wrench can't handle the heads, it doesn't have enough power. With its half-inch square drive, I loosen bolts with a breaker bar first, then use the impact wrench to remove them. I finally got this impact wrench with a 3/4 inch square drive. This impact wrench should easily loosen cylinder heads, flywheels, main bolts, and connecting rod bolts. So now I'm unpacking it, checking what's included. I don't know yet if the fitting will fit, but it looks like it should be the same. So in the set we have 3 impact sockets, 32, 36, and 41 millimeters, all 6-point. There's nothing else here. And here is the tool itself, a powerful heavy gun. So we don't have a fitting. Let me check, I should have a fitting somewhere. So I've removed the heads. The gun works great, it unscrews bolts without any problems. I also tried unscrewing 2 main bolts. The main cap bolts also unscrew and screw in without any issues. So now it will be much easier to work with the engine because unscrewing these 36 bolts by hand takes effort, time and so on. Here everything is much simpler, much faster, so the gun is excellent thanks to the people who helped me buy it. On the 3rd cylinder and on the 5th, well for now, visually, on the 3rd and 5th the sediment bowl is separated, so here we have a sediment bowl. And we can see that the sediment bowl already has the wrong shape, the hole is the wrong shape. On the 6th it's basically good, on the 4th it's good, on the 2nd I'm not sure, it needs to be cleaned, and on the 1st everything seems fine too. The problem is with the sediment bowls on 2 heads. About the heads, I'll wash and clean them myself after checking the machine, no need to take them elsewhere. Well, when you take apart the valves, you check them, check the guides, I mean as usual, everything as always. Next, what do I do next? I need to take apart the front here, remove the mount, the pulley, the pump, the bracket, then remove the cover where I'll take out the pistons, take out the shaft. I removed the third piston by unscrewing and taking out its connecting rod. And what do we see? We see that the bearings have turned into this kind of foil, like a tin sheet. The bearings are fully worn, but the crankshaft isn't entirely broken. So here we have a crack right here along the cheek, and there's a crack along the journal itself, but it hasn't completely broken. Well, when we take it out, it might break into two pieces, or maybe not. We'll see. So what else did I notice? It turns out this connecting rod is new. So all these 5 connecting rods are still the original German ones from the factory, but this particular connecting rod is from the company BF. Even when we look, the numbers font is different. There's a BF number at the bottom, and the BF logo is here. If we look at the original connecting rod, the number is stamped in a completely different way here. I've noticed several times that these connecting rods from Bibo to F, they haven't performed well, they don't behave properly. So what's the problem with these connecting rods? When it's assembled, if we measure the inner diameter, it will have a perfectly correct shape, meaning it will be completely round and the size will be the same everywhere. But over time, what happens to this connecting rod? It becomes oval shaped, meaning that in these places right here it takes the greatest load. It turns out exactly 180 degrees. On this side, the connecting rod cap also takes the greatest load, and over time it becomes oval shaped. Here it stretches and there it compresses. I've noticed this several times, and as we can see, the problem is exactly with this connecting rod. Out of 6 rods, it's this one, the B.F brand, which is not the original. So what do I think? I think the connecting rod got deformed, then the bearings started to move around, and over time they seized up. One bearing got stuck on another, it spun, got welded to the connecting rod, and welded to the crankshaft journal. You can see the driver didn't stop or turn off the engine right away, so he kept driving briefly. That's understandable since the engine is at the back of the bus, maybe 15 meters away, plus there's sound insulation. It's hard to hear right away that the engine started knocking and so on, so the bearings seized up. So what happens is that this journal is holding it, trying to keep it in place, while the rest of the crankshaft journals are spinning. As a result, the crankshaft faces twisting, bending, and other loads. This isn't the cause of the failure, but a result. The failure was caused by the connecting rod, in my view. So it's still the connecting rod, since this has happened to me before. These connecting rods are being reconditioned, but I probably won't use them again. So now I'm removing 2 more pistons, taking them out, removing the caps, taking out the crankshaft, and we'll see if it breaks or not. I disassembled the engine, removed it and the camshaft, but didn't find anything else noteworthy. The main problem with this engine, it turns out, is with us. The crankshaft is a consequence, but the cause is the connecting rod. That is, the connecting rod, as I already mentioned, is from the BF company. So in my opinion, the connecting rod got deformed. The bearings got squeezed in one area, were loose in another, then welded to the connecting rod journal and spun. Since the engine kept running for a while, it turned out that when they were towing it, they also started the engine. Basically, they had to pump up the air and so on, since the engine had to keep running for a while longer. So we see that a crack appeared, but the crankshaft didn't break completely, the crankshaft didn't snap. Oh, well, of course you can't use it anymore. It's definitely going for scrap now, that's 100%. The crack starts here, somewhere around this spot, and visually you can't see it going any further. And also along the journal, meaning it goes all the way along the journal, then it transitions onto the crank web like this, and continues in this direction. So it's over halfway through. The crankshaft broke. I was just trying to lift it with the tester by this journal to see if it would break off or something like that, the crankshaft and so on. So it's still holding on pretty tight, but when you lift the crankshaft by one end, the crack moves and you can see oil seeping out from there. In my opinion, all this happened because of the connecting rod. If, for example, we had a regular standard factory original connecting rod, I think this situation wouldn't have happened. So in short, what decisions were made about the engine? The block isn't going anywhere. For machining, specifically the main bearing seats and main bearings, the repair will involve replacing the crankshaft, while the pistons and possibly even the piston rings will remain unchanged. So I'll need to take them off, measure them, check the clearance and wear and so on. There were no complaints about this engine. It used no oil or fuel, had good power, didn't smoke, and had no problems. We're going to repair this engine with minimal investment, meaning we'll buy as few parts as possible. Maybe I'll replace the seals, maybe not. We'll see as we go. The only thing is, I'll need to flush the block. We can see how much metal shavings there are. I'll flush the channel, basically clean the heat exchanger radiator, and so on. Maybe I'll even have to put head gaskets with metal seals. So before we used to buy Turkish gasket sets. They came with gaskets that had metal seals. As I already said, I don't use those gaskets because they damage the block and the head itself. Corrosion forms in this area. What else did I notice? I saw that one oil nozzle is broken. I don't know what caused it. It doesn't seem to be near the third one. Maybe it was already like that before. I'll have to replace one oil nozzle. Why is there such an attitude toward these engines? Why will this kind of repair be done? Well, because as I've said many times before, our company is losing its main route, which all these buses used to operate on. This engine will work there for only a few more months, maybe half a year. With such a short lifespan, no one will invest 150,000 or 200,000, so we'll handle repairs without extra investment. That's the interesting case. Here's the crankshaft. He didn't even break it, there's just a crack. I don't really remember seeing this in my practice, maybe just a couple of cases like this, so this is a unique and interesting case for us. It was decided to assemble this engine. Basically, we even bought a certain number of new parts. I thought it would be a very minimal repair, with a very minimal number of parts needed. Well, still, let's open it up for half a day. As you can see, the block is already prepared. I washed it, cleaned it, and blew it out. The only thing left is maybe to run a tap through some thread somewhere, and so on. We're keeping the old lifter. I washed the counterweight and the main caps. Now we'll install the crankshaft. The camshaft is also old. I washed and blew it out as well. We're also keeping the old sleeves. I cleaned off some corrosion, rust, and so on. So right here where we have the seats for the seals, I cleaned them, and inside here where there was carbon buildup, I cleaned that too, and so on. There are already signs of cavitation on the sleeves. You can see the pits, and on the opposite side there are pits as well. Well, it is what it is. We're assembling it as is. I'm starting the assembly by installing the sleeves and heat exchanger. Next, I'll lay the engine on its side and install the lifter and camshaft. We're keeping the old bushings, and then I'll install the crankshaft. The crankshaft is already prepared for installation. I've polished it and blown out the oil channels. For preparing the crankshaft, I have several boxes. I'll insert these shots now. So the connecting rod, well, the crankshaft is different, of course. The old one is broken, so we'll have a different crankshaft. So this is my crankshaft. I had a standard one prepared, but let's say as a backup option, it was lying in the workshop. It's spring, but there's still lots of snow. As it melted, the roof leaked and all my spare parts got soaked. We can see this kind of rust appeared on the neck, especially here around the 6th and 7th main bearings. So we see there's less rust in this direction, less and less, and here there's almost none left. So, I tried polishing the 7th main journal, and we can see that everything polished off. There are no traces of rust left. It's just surface rust, really. It all happened in a couple of hours. I saw that water was leaking there, removed all the parts, wiped everything down, blew it out, and so on. That's it. So, right now my task is to polish all the journals. I know they're within size.
I already checked it before, clamped it in the lathe, removed the counterweights. Now we're polishing, then we'll blow out the channels and install the channel.
I measured the main journal sizes 103.98 and 103.97, both within normal limits, only minus 2 or 3 hundredths. Next, we'll check the rod journals. The size is 89.97, 89.98, so also minus 2 or 3 hundredths, which is within the tolerance limits. So this way I prepared the crankshaft and we're starting to assemble the engine. For now I'm working with what I already have ready, which is the camshaft, sleeves and crankshaft. We assemble all of this and then we'll deal with the piston assembly. As you remember, we have a problem with one of the connecting rods. I couldn't find a piston pin bushing in the shape of a trapezoid. There are connecting rods with these cylindrical bushings, but for those you need different pistons. So I have a set of different pistons for these connecting rods, which means I might end up installing pistons from another engine instead of these, meaning both pistons and connecting rods. Everything is assembled, but that's for later. We'll get back to it. For now we're working on what I mentioned earlier. Let's go. I measured how much the liner stuck out above the cylinder block. Currently it's around 9 to 10 hundredths for each, all within 1/10 overall. So I had to adjust a bit here, put in 2 rings, some thicker, some thinner, and so on. So there's a slight variation. Now I'm marking each sleeve according to its position and orientation, making marks, taking out the sleeves, installing new seals, and then putting the sleeves back in place. So I've tightened this to 200 Newton meters. Now we're setting the wrench to 300 Newton meters and tightening all the bolts again with a force of 300 Newton meters. So the crankshaft is fully installed and tightened, meaning the main journals are tightened, the pistons and connecting rods are installed, the rod journals are tightened, the counterweights are installed, and the counterweight bolts are also tightened. I'm applying thread locker and ensuring each connecting rod moves freely. The crankshaft also moves axially. So I also turn the engine and check that the oil jets go into the piston recess. That is, nothing is hitting anywhere, there is no misalignment or anything like that. That's it, the crankshaft is installed and tightened. Now, as usual, I install the front cover, the rear cover, replace the seals there, and then close the oil pan. I installed the oil pan, tightened the bolts, and put the gasket on with sealant as usual. The oil pan is not from this engine, this is a different oil pan. So why did I decide to replace the oil pan on the original oil pan that came with this engine? The thread is stripped here, and I think it's already been drilled out to about 14 millimeters. The original oil pan from this engine has welding here, it's been welded and so on, so here's what I need to do now. Now I need to install a plug here, screw in a fitting for the oil dipstick here, install a bracket for the alternator mount here, and temporarily close off the oil filler neck with a plug here. And it looks like I'm missing a bolt right here. Here on the cover I have a 10 mm thread, while everywhere else it's an 8 mm thread. In this spot on the cover I have a 10 mm thread. I need to enlarge this hole with a drill bit to about 10.5 mm, then install a 10 mm bolt. That is, I forgot to do this right away. After installing the oil pan, I noticed my bolt was falling through and remembered I have a 10 mm thread here. That's it, so that's how it is. We still have work to do with the oil pan, and then when we're done with the oil pan, well, I don't know, maybe the pulley. We need to install the water pump, fuel pump, and possibly the compressor, though I'm not sure about the compressor. I'll open it up to check the cylinder and rings. I still have the unprepared cylinder heads, so I'll need to disassemble and inspect them. Everything's the same there. Valve seals, seats, valves. Wash everything, blow it out, clean it. Alright, so we continue the assembly. Some time has already passed for me. I was working on the cylinder heads. So about the heads I'll explain briefly. Because the engine worked. I didn't do anything special with the cylinder heads. Well, I washed them, cleaned them, blew them out, disassembled a few heads, checked the condition of the valves, did everything there, the seals and so on. Everything is working. I've prepped the guides, bushings, bolts, and cleaned the gaskets. We can see that some of my gaskets are metal with rubber seals, and some are these metal ones. These are asbestos. I'll explain why. For example, if we look at these two heads, we can see on this one, yes, we have a sediment chamber, a channel that's in the head but not in the block, and it's in the correct shape. And here this kind of head will fit well. We can see that its sealing is done with this kind of rubber ring. You can see the imprint from this ring, and it ends up blocking this channel. Looking at the neighboring head, we see the sediment chamber is corroded and eaten away like this. For comparison, here you can see its shape and size, and on this head you can see its shape and size as well. So if we put this kind of gasket here, this ring doesn't actually cover it. That is, you can even see by the mark that it was already almost right on the very edge. But everything here was still dirty, yeah, rust, some deposits and so on, now that I've washed and blown everything out. So the chances that if I use this kind of gasket, it just won't cover this corrosion, and the gasket itself is metal. It will hold, so here we'll have some leakage, well, coolant. So we have two of these heads. I put them on the 5th and 6th cylinders. I've marked them, so these will be for the 5th and 6th cylinders. And the 1st, 2nd, 3rd and 4th will be used in these kinds of metal gaskets. I tried to assemble everything with these metal gaskets that have a rubber seal. But in this case, I kind of end up in a hopeless situation. Yeah, I either need to replace the heads, which I don't have right now in good condition, or I can get out of this situation by using these kinds of gaskets. So that's it, that's the nuance. Let's start installing the heads. so the engine is almost assembled. All that's left is to install the compressor, the exhaust manifold, and the clutch basket. We'll have a new clutch basket with a disc, so we'll get back to the basket later. I'll probably paint the manifold, so now I need to prepare it for painting. I'll paint the manifold separately, then I'll paint the engine separately, and only after that will I install the manifold on the engine. So, about the compressor. I want to take the compressor apart. The compressor is still lying on the shelf. I haven't even washed it or cleaned it at all yet. Still, I need to take it apart and check the condition of the rings. That is, check the condition of the cylinder itself and the piston rings. I likely won't disassemble it further, just to the rings and gasket. The plate is already installed. So I'm working on the compressor, installing the compressor, then preparing the engine for painting. Prepared and installed the manifold for painting, then started it up. I'm unsure if I will or won't. It depends on the circumstances. For now, I'm working on the tasks I mentioned. installed the compressor. There was minimal repair on the compressor. I replaced the piston rings, replaced the bearings, replaced the valves, cleaned the carbon deposits, put in new gaskets. So just a minimal repair. I installed the compressor and tightened it. So basically that's it. My engine is almost assembled. What am I doing now? Now I'm preparing the engine for painting. Well, as usual, I'm covering the grooves with tape and also the fittings, some sensors and so on. I will also need to install. The exhaust manifold is already prepared. I also need to repair the fork. I have the repair kit for the clutch fork. So as you can see, the shaft spins like this. There are needle bearings inside, and apparently there's wear on the needle bearings. Well, I also need to install the starter. I'll paint it without primer. For example, I painted my previous engine without primer. And when I took it apart again, it seemed to me that the paint held better that way. That is, it somehow sticks to the metal better, than when it's applied over primer. So we'll also try painting this engine without primer. Let's see what we get. I'm not sure about painting yet. I'll see if I have yellow paint, then use the same yellow as D3900. So I installed a new clutch basket, a new clutch disc. Before installing the disc, I took it to a lathe and checked the runout. Well, basically lately I haven't come across any bent discs for quite a while, but there were a few cases in the past when the disc was warped. We installed it without checking. The basket moves, but there's not enough space for the disc to disengage or the gears to engage. We had to remove the gearbox multiple times and struggled with it, so now I always check the disc for runout. That's it, so I installed the disc, installed the basket, already adjusted the basket. Basically I set these levers by just 0.5 millimeter. You loosen these bolts and these posts, you can move the basket closer to the release bearing, or further from the release bearing, that's all. So my engine is assembled, my engine is painted, meaning the engine is completely ready. Next will be the startup. The startup will be right here on the table. So there will be a separate episode about starting this engine, but for now I'll be finishing the assembly episode for this engine. That's the kind of video we got. Thank you all for watching. Good luck to everyone. Goodbye.